Hi, I'm Bob Tabor with LearnVisualStudio.net. In this lesson, we want to backtrack just a little bit and talk about the async features in the Win.js library. And so we've seen traces of this a couple of times up to this point. I think what kicked off this conversation was the then function that we saw whenever we pasted this Win.js XHR feature into our data.js file. I said at the time that this kicks off a JavaScript promise, and I said I really don't want to talk about it right then. But we see it sprinkled throughout the grid app template. If you take a look in the default.js, you'll see this args.setPromise with the then function invoked as well. And if you take a look at the navigator.js, there's several other instances of this spread throughout. So in this lesson, what I want to do is just talk about at a high level what is asynchronicity and how is it implemented in the Win.js. And so for the most part, what I'm going to be doing is spending time talking about the topics that are more eloquently presented in this MSDN file, the Asynchronous Programming in JavaScript webpage on MSDN, and I'm going to borrow some of these examples and some of the explanations and maybe spice them up just a little bit. But what I want to do is start by talking at a high level about your app. So when your program actually launches in Windows, it's executed in a process, which is simply an isolated sliver of the computer's memory and CPU. Each process that's currently running is separate, so that if one process goes bad, then it won't necessarily affect all the other processes. So if there's a memory leak or the processor is busy on a long-running process, it shouldn't necessarily affect all the other processes that are currently running. So each process owns a thread of execution. A thread of execution is simply just an execution path that can work independently of other execution paths. When you create an app, by default, your app is single-threaded, meaning that there's a single path of execution, a single set of steps through the application. So if you were to be able to have a superpower of super slow motion and you could watch code as it executes line by line, you would just watch it in a very linear fashion, all right? It wouldn't be jumping all over the application, indicating that there were multiple threads or paths of execution going on at the same time. No, you would watch it in a very linear style, okay? Hard to explain. Hopefully you'll understand. There's just one path that the execution path is following, okay? So what does all this mean? It means that invoking a long-running process on your single thread blocks all execution on that thread until the process completes. So that means that UI elements become unresponsive. The user keeps clicking on a button and nothing's happening because there's something blocking the execution. It means that animations pause or they're stilted, and ultimately no other code in the app can run while something is blocking execution. The solution to this problem is to avoid synchronous execution as much as possible. But if we avoid synchronous execution, that means we have to find a different means of handling this scenario because, again, we're only working with one thread. So one option is to define a function that should execute later, once a given long-running operation has completed. And this is what event handlers are for, frankly. We attach functions, possibly anonymous functions, to events that'll be executed whenever that event is triggered. And you can see many examples of this in our app. Here's a quick example in the default.js on line number 12. Here we're adding an event listener for the activated event, and when that event is fired, all this code is executed. And so callback functions are another kind of asynchronous processing because they call back into the code that initiated the process. And jQuery uses these all over the place. So here's a quick jQuery example, something that maybe we even could pull from our JavaScript Fundamental series. So you can see in this case, that after the fade in has completed, then we can execute this other function, this anonymous function that's defined after the fade in has completed, okay? So it calls back. The trick with callbacks is that they can be nested making them very, very difficult to debug and manage. So here's a more complicated example. Here we fade in one item, and when it's done, we fade in another item, and when it's done, we fade in another item. And so if something bad were to happen in that last callback, then we have really a hard time trying to figure out where the problem actually originated. So the use of anonymous inline functions can make reading callback, the call stack rather, problematic. Exceptions that are thrown from within a heavily nested set of callbacks might not be propagated up to a function that initiated the chain. This makes it difficult to determine exactly where a bug is hidden. The Windows runtime and the Windows library for JavaScript provide a way to overcome these problems through the idea of a promise. And a promise is basically just an object that returns a value at some time in the future. It's like an IOU. I write it down on a sheet of paper and say, here, at some point in the future, I will pay you back. All right. So you can use these objects to construct chains of asynchronous code that are easier to read than callbacks. This is actually an implementation of a standards-based proposal that soon to be a specification called the CommonJS Promises/A specification. And I'd encourage you, there's a whole website devoted to this spec, okay? But this promises implementation is the WinJS implementation of that spec. So all of the runtime APIs that are exposed to the Windows Store apps, they're wrapped in promise objects. So this allows you to use the Windows runtime APIs in a way that you're comfortable with. The promises in the Windows library for JavaScript are important because many interactions with the Windows runtime are asynchronous. So here's a quick example on screen that we'll leverage in a future lesson whenever we talk, I think like lesson 25, 28, somewhere around there, about trying to take a picture using the webcam. And so there's a lot of code here. I've taken this completely out of context, and there's a few variables that you don't see defined, which is okay. I want you to focus on the capture file async function. It promises to return a file in the future once the user has taken the picture from the webcam. Once that finishes, then the then function then will execute an anonymous function that reports the status in a message element. That's a pithy example, but you can see how promises are used in the Windows Runtime API. And you know, they're used often. In fact, the Windows library team, the Windows Runtime API library team, they decided that any operation that could take potentially more than 50 milliseconds needs to be wrapped or to be async in nature. So they're taking this very seriously. They want apps to be responsive and always ready to work. So a promise is simply an object. The most frequently used method on a promise object is the then function, as we've seen, which simply takes 3 parameters. And let's see, in our given example here in the data.js, we're only giving it one of these 3. But basically, it can take 3 parameters. The first one, the one that we've used here, is a function to call whenever the promise completes successfully. But we can also give it a function to call when the promise completes with an error, and then a function that will provide progress information. And so beyond that, you can also join multiple promises together. So for example, you can use the join function to run multiple asynchronous operations that call several web services and then aggregate all the results together. So in this particular case, you can see this little pithy example of load data. We give it a number of URLs, and then we want to use the array.map function to convert the array of URLs into an array of promises, because that mywebservice.get returns a promise. And finally, we want to use the join function, which accepts an array of promises and returns a new promise that will complete after all the promises have completed. Then we do the data aggregation inside the complete function of the then function. Okay, so in my opinion, the best place to learn more about promises is to actually see it in action for yourself. And there's a promise example app available for download from code.msdn.microsoft.com. You should see the URL on screen. It's this Win.js promise sample, and I've already downloaded it and extracted it to my hard drive, and I've placed it on the C drive as this Win.js promise sample. And if you drill into the JavaScript subfolder and just double click the promise.sln file, and then it'll ask a few questions. Maybe the first time you run it, are you sure this code is safe? Go ahead and say yes to that. But when you run it, it is a Windows 8 app that allows you to test asynchronous events, like here's just an asynchronous promise, a timeout scenario, and so on. And the great thing about it is then you can come back into this example and begin to pick apart the HTML and JavaScript that actually runs this. So we would look at, for example, the create async promise.js, and we can look at all of the code and all the comments to kind of understand how it's doing what it's doing. But I'll leave that to you to do on your own. So now that we've focused a little attention on promises, you can see that the Windows Runtime API pushes you towards asynchrony by implementing many long-running tasks involving the file system or HTTP and many others as asynchronous methods. In fact, the team decided very early on that anything that could potentially take more than 50 milliseconds needs to be an async task in the Windows Runtime API. It's safer and easier than creating embedded callbacks like I talked about a little bit earlier. Okay, so now we're ready to get back into modifying our user interface. We're going to pick it back up in lab number 1, exercise 3 in the next lesson. So we'll see you there. Thank you.